All right, guys, today what we're going to be looking at is the practice test that we took in class, and I'm just going to go through each problem. So this is an opportunity for you, if you've got questions about a specific problem, to review that specific problem. You don't have to watch the whole video. You can fast forward to the areas where you have questions. So we'll go ahead and jump in and start with question number 1. It says, which of the sets shown includes the elements of set Z that are both odd numbers and multiples of 5? So the two sets that I'm looking for are odd and multiples of 5. And so the first thing I'm going to do is I'm going to underline the odd numbers in set Z. So negative 15 would be odd, 7 would be odd. That's it. All right, then I'm going to circle the elements that are multiples of 5. So negative 15 would be a multiple of 5. Negative 12 would not. Negative 10 would be a multiple of 5. 2 would not. 7 would not. But 10 and 20 would both be multiples of 5. And so now that what I'm looking for is I'm looking for things that I underlined and things that I circled, because I want what they both have in common. And the only thing I see that I underlined and circled is negative 15. So my answer here would be choice A, negative 15. Number 2 says order the numbers from least to greatest. Because these numbers are all in different forms, I'm going to use my calculator to first figure out what they are all in decimal form so that I can compare more easily. So if I take 25 divided by 7, I end up with an answer of 3.57, and it continues on, but I'm going to stop there for now. 3.6 is already in decimal form, so I can leave that one alone. The square root of 12, remember that square root is on the left-hand side, and we're going to have to hit second x squared to get that. And it turns out to be 3.46. And then finally, second x squared to get the square root of 49 divided by 4. And I get this answer is 3.5. So now that they're all in decimal form, I'm going to put them in order. And so it looks like they all start with 3. So then I go to the first number after the decimal point. I've got a 5, a 6, a 4, and a 5. So it looks like the 4 is first. So 3.46, but remember I want to write it in its original form. So I'm going to say the square root of 12 is my first number. All right, then I go to the next one. I'm looking for the next biggest, and I see a 3.57 and just a 3.5. So because this one continues, it's a little bit bigger than this other one, and so I'm going to say the square root of 49 fourths would be next. And then close after that would be the 25 sevenths, which leaves finally my answer of 3.6, from least to greatest. All right, question 3 says, what is the value of x in this equation? So they're just asking me to solve the equation. So since I see parentheses, the first thing, oops, I forgot the 2. The first thing I'm going to need to do is get rid of those parentheses, either by dividing or distributing. I think in class, most people prefer distributing, so I'm going to start with that. 3 times 2x is 6x, and 3 times negative 1 is negative 3. All right, goal is to get x by itself. So since it's attached to the 6, I'm going to start by adding 3 to each side and get 6x is equal to 24. And then finally, I'm going to break that 6 and x apart by division. I'm going to divide each side by 6 and get x is equal to 4. Remember, I can always check this answer by plugging that back in. So 3 times 2 times 4, that would be 8. 8 minus 1 would be 7, and 3 times 7 does in fact get me a 21. So I can be pretty confident that x equals 4 is correct. All right, moving on to number 5. It's just asking me again to solve an equation. Again, I see some parentheses, so I'm going to start by distributing that negative 2 in. Don't forget that sign goes with the problem. So I haven't done anything with the 5x, so I'm just going to bring it down. But the negative 2 times 2x becomes a negative 4x, and the negative 2 times negative 1 becomes a positive 2, all equal to 6. Now again, before I start actually solving, I'm going to simplify so I can put that 5x minus 4x together, and that actually becomes a 1x plus 2 is equal to 6. Final step here, I'm going to subtract 2 on each side. Since it's adding 2, that would undo the 2, and I'm left with 1x is equal to 4. I can divide by 1 if I want, but really what I get is that x is equal to 4. Again, if I've got time, I can come back and check that by plugging that in everywhere I see an x. And I can let my calculator do the work by plugging it in just as I see it. Number 5 says the sum of 3 consecutive odd integers is 105. What are those 3 numbers? If you'll remember, the strategy we developed to figure this one out is we took 105 and divided by 3. And when we did that, we got 35. This, in fact, means that 35 plus 35 plus 35 would equal 105. But that's not what we're looking for. We're looking for 3 consecutive, which means in a row. So I'm going to make this one smaller, and I'm going to make this one bigger to make that work. So because they're odd, I'm going to stick with 33. That's 2 smaller. I'm going to keep the middle number, 35, and then go 2 bigger over here and check 37. If I try those in my calculator, 33 plus 37 plus 35, I do in fact get an answer of 105. So I found my 3 consecutive odd integers that add up to 105. All right, it looks like the next few problems are solving equations. We just need to read carefully what they ask. So 6 says, what is the value of x? That means solve. So I'm going to start with negative 4x plus 1 is equal to negative 19. Since x is trapped up with the negative 4, I'm going to start by subtracting 1 on each side. And I get negative 4x is equal to, now, negative 19 with a negative 1, that becomes a negative 20. Think about a number line. If I start at negative 19 and take 1 more away, I'm at negative 20. All right, then I'm going to divide by negative 4 on each side, and I do get an answer of negative 20 divided by negative 4 gives me an answer of positive 5. And again, I can always check those answers as I go. All right, number 7 says, how many solutions are there to this equation? So guys, this is not asking what the solution is, it's asking how many. So my only answers are either one solution, many solutions, or no solutions. Now to find that out, I'm going to have to solve. So I'm going to start by distributing because I see some parentheses. So I'm going to distribute. So I end up with 7x minus 3x plus 3. Remember that negative 3 times the negative 1 becomes a positive 3. On the other side, I end up with 2 times 2x, which is 4x, and 2 times 3, which is 6. All right, I'm going to do a little simplifying because I see multiple x's on the same side, and same side means just combine. So 7x minus 3x becomes 4x plus 3 is equal to 4x plus 6. All right, now that I've simplified each side, I need to work on getting my x's together. So I'm going to start by moving these 4 x's over to this side. But an interesting thing happens when I do that. 4x's minus 4x's eliminates, and I'm left just with a 3. And then 4x's minus 4x's eliminated, and I'm left just with a 6. Guys, when I have no x's left, no variables left, that means I need to look and see if this answer makes sense. So is it true that 3 equals 6? And that answer is not true. And so that tells me that there are no solutions to this problem. Number 8 says, what's the value of x in the following? Again, when I look at this one, x is being trapped in that division problem. So I want to start by adding the 7 to each side. And when I do that, I end up with x divided by 3 is equal to 11. Now I can worry about getting that x free. Since it's being divided by 3, I'm going to undo that by multiplying each side by 3 because multiplication and division are inverse operations. When I do that, I end up eliminating the 3 because division by 3 and multiplication by 3 cancel each other out and just get an x. And then 11 times 3 is 33. Again, this is one that sometimes we struggle with, and so make sure you remember, since the x is trapped with a 3, remove that 7 first, that negative 7 first by adding, and then deal with the division. All right, number 9 is just what we've been doing. However, we've got some fractions involved this time, but we can handle that. So use your calculator to multiply. 1/3 times 6x, that simply becomes a 2x. And 1/3 times -5, I'm going to leave that just as a fraction so I have my good exact answer. So I'm going to leave it as -5/3. And then I still have a minus x hanging out there on the left side. On the right side, I'm just going to bring down the 1/3, but then I'm going to distribute that -2. So -2 times x would become -2x, and -2 times 1 would become -2. All right, I'm going to simplify a little on each side, so I'm going to combine x's. So 2x's minus an x becomes just an x. I still have that -5/3 on the left. On the right, I'm going to combine the 1/3 and the -2. So if I use my calculator and take 1/3 minus 2, I end up with -1 and 2/3, and I still have the -2x. All right, now I've simplified each side, and so now I need to work toward getting x's together. So to keep things positive, I'm going to add 2x to each side. So x plus 2x on the left becomes 3x. I still have the -5/3, and it's equal to -1 and 2/3. Now working towards getting that x by itself, since it's trapped connected to the 3, I'm going to add 5/3 to each side. And when I do that, I find out that -1 and 2/3 plus 5/3 actually gets me a 0. And although that seems strange, since I still have an x involved, I'm still continuing to solve this problem. And so to do that, I'm now going to divide each side by 3 to get x by itself, and x actually equals 0 in this case. Again, sometimes we feel a little uncomfortable with that answer, but we can plug it in using our calculator and find out that that does in fact give me a true answer. All right, finally, number 10 says y equals ax plus b, and it says solve for the variable x. That means get x by itself. So I first locate the x, and I see that it's trapped here with the a. So I'm going to start by adding b. Since it's subtracting b, the inverse would be adding b to each side. And I end up with y plus b is equal to a times x. Now, ax right next to each other means that a is being multiplied by x. So to undo that now, I'm going to divide each side by a. A divided by a cancels out, so I finally got x all by itself. And what I'm left with is y plus b all divided by a. All right, the last two problems on this page ask us to solve, again, an equation, this time with some decimals. And so I still see parentheses, so I'm going to start by multiplying in. So 0.45t, and then 0.45 times 8 becomes 3.6. On the other side, I'm going to take 0.6 times t, which becomes 0.6t. And 0.6 times -3 becomes -1.8. Now, there's nothing else I can do on either the left side or the right side to simplify, so now I'm going to work toward getting my t's together. There's really multiple ways I can do this, but I'm going to start by subtracting 0.45t from each side. When I do that, I end up with just having 3.6 on the left, and then 0.6 minus 0.45 becomes 0.15t minus 1.8. All right, next I'm going to add 1.8 to each side, and I'm going to be left with 5.4 is equal to 0.15t. And my final step now is to break the 0.15 and t up, and so I'm going to divide by 0.15 on each side, and I end up with actually 36 is equal to t. And again, may seem like a strange answer, but if we plug it in, we find out that that does truly work. All right, number 12 says solve and graph this inequality. Guys, nothing changes from what we have done. We just have to remember with inequalities that if we multiply or divide by a negative number, we need to flip our symbol and we need to graph our final answer. So if I look at this problem on the left side, there is nothing I can do. But on the right side, I can distribute. So I'm going to rewrite the left side as 3x minus 8. And the right side, I'm going to distribute to get 4x minus 6. That 4 times negative 1.5 is 6. All right, now I'm going to work toward getting my x's together and my numbers together. This can go in a number of different places, and so your solving may look different than mine, but I'm going to choose to subtract 3x from each side. And when I do that, I end up with negative 8 is greater than or equal to 1x minus 6. Then I'm going to add 6 to each side and get negative 2 is greater than or equal to 1x or just x. This is a fine answer and you would get full credit for this. However, I like to write it where my x is on the left. So since the inequality symbol is pointing to my x, I'm going to continue pointing to my x when I flip it around and get that x is less than or equal to negative 2. Now, in my particular problem, I never multiplied it or divided by a negative number, so I did not need to worry about flipping my sign on this one. However, there are opportunities in this problem, if you solved it in a different order, that you may need to do that. So don't forget that step. All right, because it's a less than or equal to, I'm going to find my boundary of negative 2, and I'm going to fill in a solid dot at negative 2. Then because it's less than or equal to, I'm going to shade to the left to get those values that are less than or equal to. I'm not really sure why that drew a whole line there, but it should just be the negative 2 and to the left. All right, last page. Similar instructions to the last one. Solve the inequality. I see parentheses, so I'm going to distribute. So when I distribute, I get 4x plus 12. I still have that minus 7. On the right side, I bring down the x, and then when I distribute the 3, I get 3x plus 3. Now, this one I'm going to simplify a little bit on each side. So the 12 minus 7 becomes 4x plus 5 is greater than or equal to, and when I simplify on the right side, x plus 3x also becomes 4x plus 3. I'm going to work on getting my x's together by subtracting 4x from each side. And I end up with 5 is greater than or equal to, let me start that over. 5 is greater than or equal to 3. Now again, just like we had with our equations, when we eliminate our variable, it means something. It either means no solution or many solutions. Inequalities are a little tougher because I have to look at it and see, does this answer make sense? So is it true that 5 is greater than or equal to 3? And my answer is yes, that is true, which means this is an infinitely many solution. Now, this particular problem didn't ask me to graph it, but if it had, it would be the number line, and every single bit of it would be shaded because infinitely many means every number on the number line works. All right, jumping down to number 14, we're graphing and solving this inequality. So I'm going to start with distributive property, and I get a negative 12x minus 10 is less than or equal to 38. Since the x is attached to the negative 12, I'm going to start by adding 10, and I get negative 12x is less than or equal to 48. Then I'm going to divide by negative 12. Uh-oh, red flags, bells, whistles, stuff should be going off in your head because I've got an inequality and I'm dividing by a negative number. That means I have to flip my symbol, and then 48 divided by negative 12 becomes a negative 4. So because it's a greater than or equal to, I'm going to put my boundary dot at the positive or at the negative 4, and it's going to be closed in. And this says I want x's that are greater than or equal to negative 4, so I'm going to shade to the right. Remember, the way we can check an inequality is pick a number in that shaded region and check it out. So I like 0 if it's in my shaded region. If I plug in 0, 6 times 0 is 0, plus 5 is 5, and negative 2 times 5 would make this side negative 10, and negative 10 is in fact less than or equal to 38, so I can feel good about that answer. Number 15 says solve the compound inequality. Compound just means two at once, so I'm going to solve each one separately. So 3x minus 4 is greater than 5. I'm going to start by adding 4 to each side and get 3x is greater than 9. Dividing by 3, so far I haven't done any division by a negative, so I've got just that answer, x is greater than 3. Now I see the word or, so I'm going to keep the word or, and now I'm going to look at the second inequality. 1 minus 2x is greater than or equal to 7. I'm going to start by subtracting 1, because even though it's a subtraction problem, that's a positive 1. And so when I subtract that 1, I end up with negative 2x is greater than or equal to 6. And dividing on each side by negative 2, again, bells and whistles, I've got to flip my symbol. I end up with x is less than or equal to negative 3. This one didn't ask me to graph it, so I can stop right there. But if they had asked me to graph, I would have an open symbol and a closed symbol, and I would be shading out. So at the 3 to the right and at the negative 3 to the left. Number 16 asks us simply to write a compound inequality for this graph. Guys, you can do this in two ways. Because it's an and everything is stuck together, we can write it as one compound inequality, putting the negative 3 first, because it's a solid dot saying less than or equal to x, and then looking at the 2, and because it's an open dot, just leaving it as a less than symbol. So that's the first way, or you can write it two separate ways. You can say x is greater than or equal to negative 3, and x is less than 2. If you prefer to write it in those two parts, either of these answers would be acceptable on number 16. All right, finally 17 and 18 get to absolute value equations. And so what we have to remember with absolute value is we're always going to get two answers. And before we can split it up into two problems, we have to get the absolute value all by itself. So in this case, because there's a 4 over there and it's not inside the absolute value, I'm going to start by subtracting 4 from each side. And I'm then left with a negative absolute value of x is equal to 1 minus 4, or negative 3. Now, we might think we've got that absolute value by itself, but there's still that negative out front. So I'm going to divide each side by negative 1 to get rid of that. And now I'm left with the absolute value of x is equal to a positive 3. Now I'm ready to split to get my two answers. And to do that, the first time I write it just as I see it, x is equal to 3. The second time I write it with the negative solution, so x could also be equal to negative 3. And there are my two answers. X could be 3, and x could be negative 3. All right, finally 18. Just like what we talked about before, it's an absolute value, so I know there will be two solutions, but I also know I have to get the absolute value by itself first. So I'm going to subtract 2 on each side. 4 minus 2 is 2 is greater than x plus 1. All right, now the absolute value is all by itself, so I'm ready to split into two parts. The first part, I write it just as I see it. 2 is greater than x plus 1. The second one, I use the negative answer, and because we're dealing with inequalities, I flip my symbol to get the second problem. All right, finally solving, it's a simple solution. I just subtract 1 on each side, and I get 1 is greater than x. And over here, I subtract, and I get negative 3 is less than x. Now, again, these are fine solutions, but I like to write them the other way. So the first one, the inequality symbol is pointing to the x, and so I'm going to leave it pointing to the x. And the second answer, the inequality, it's opening toward the x, so I'm going to leave it opening toward the x. So as I graph this, I've got an open circle at the 1, and x's are less than 1, so I'm going to come this way. The second one, I have an open circle at negative 3, and I'm coming this way. And so because I've got lots of shading here, I need to figure out exactly where that works. And so I'm going to first test in between, and it looks like 0 is an answer that's in both shaded regions. So if I plug that in, 0 plus 1 is 1. The absolute value of 1 is 1, and 1 plus 2 is 3, which makes that statement true that 4 is greater than 3. So I know I want to shade in between. Now, just to be on the safe side, I can test these other areas. So maybe I'll try a 2. If I take 2 plus 1, that's 3, and the absolute value of 3 is 3. 3 plus 2 is 5, but 4 is greater than 5 is not a true statement, so I don't want to shade this area. I could do the same and find that I don't want to shade this area. All right, guys, that takes us through our practice test, each question, and I hope you found that helpful. If there's anything I or Mr. Jordan can do to help you, please let us know. We'll talk to you later. Happy studying.